Okay, number 58 on your practice final here. Determine which of the following correctly uses the intermediate value theorem to show that the graph of the function has a 0 in a given interval. Find the value of the 0 to 2 decimal places. So what happens here is we have this function, and what it's telling us is that there's a 0 in between 2 and 3. So somewhere between x equals 2 and x equals 3, there's a 0 in that interval. Again, thinking about zeros again, that means the y value is 0, somewhere in between there. So what we want to do is the intermediate value theorem. You got to be able to understand the intermediate value theorem. So looking at a graph, let's say we had the intermediate value theorem. Okay, and then this is 2 and 3, and it's saying that, okay, so we're at x equals 2, so that's x equals 2, and that's x equals 3. And it's saying that somewhere in this, if this was a real function, somewhere between 2 and 3, the y value has to be 0 in between there. What it means is that one of the values is negative, the y value is negative, and then at 3 the y value is positive, so somewhere in between there has to cross 0. The key here is that, again, one of them is negative, the y values, and then one of them is positive, the y values. So let's look at the choices you have here on this problem. We're looking to see that, okay, in this problem right here, well, actually, let's look at B first here. Okay, so B is telling us that, hey, at 2, when x is 2, y is negative 5, which is less than 0. And then when x is 3, y is 14, which is greater than 0. So that's what the intermediate value theorem is telling us. It's saying that if one of them's negative and one of them's positive, then there has to be a value in between those two. Well, what it's saying here is that at negative 1 it's 0, but that's not in between 2 and 3. So we know that's not correct. Okay, let's look at A here. Okay, in A, all it's telling us is that, oh, okay, at x equals 3, y is 14, x equals 2, y is negative 5. But it's saying that 14 is greater than negative 5. Okay, that's true. 14 is greater than negative 5. That's pretty obvious. But the intermediate value theorem is trying to tell us that, again, one of the y values is negative, or less than 0, and one of the y values is positive, it's greater than 0. So this is not correctly using the intermediate value theorem. Okay, that also goes for D here. This is not correctly using the intermediate value theorem. Okay, the only one that's correctly using it here is, again, right here. You can see it's saying that one of them is negative and one of them is positive. Therefore, somewhere between 2 and 3, so in this case 2.41, there is a 0 in between there.